welcome everyone, and just some sort of ground rules. Hopefully we can keep this informal, and if you have any questions or anything comes up as we're talking through this, feel free to jump in. We've got a Q&A section. Yeah, I don't know, Carolyn, did you want to jump in and tell people how they can interject and ask questions?
Yeah, absolutely. We have the Q&A down at the bottom and the chat, so you guys can go ahead and write in any of your questions, and down at the end we will get around to those. In addition, if there's any that we don't get around to, we'll be sending a follow-up email that will have answers to those questions that we didn't get around to today.
Great. Okay. And okay, so I have all my windows ready. So I'm Jay Jacobs, data scientist and co-founder here at Scientia, and one of the lead analysts on EPSS. And Ben?
I'm Ben Edwards. I am also a data scientist here at Scientia. And as Jay tongue-in-cheek put it there on the slide, a smarty pants. So I contribute to EPSS largely by telling Jay what he should do for his next step. After he's done all the hard work, I get to kind of come in and play. Now, what if you do this instead? And so I'll be injecting those kind of smarty pants PhD level remarks throughout the webinar.
Yeah, good times. Okay, well, let's jump into it. So what we are going to cover, and we're going to hopefully breeze through these a little quick, maybe not hopefully, but we're going to breeze through them a little quick and try to leave some time for questions. I think it's always the most important and interesting part of this anyway. So we're going to just introduce people to what EPSS is and talk about how EPSS would be integrated into a program. Talk about what goes into EPSS, and the first part is basically here's what EPSS is and how you can use it. The last two sections are why should you use it? Getting into what is it doing and why should you have confidence in it. So first and foremost, we're going to be keeping this somewhat high level. We do have a paper that we just pushed a week or two ago. It's on arXiv, and if you just search for this title, it'll come up. I think it'll be, I don't know if someone wants to throw the link to it in the chat or anything. But this paper goes into a lot more detail than we're going to be able to cover in this discussion, and it's written for people to really understand what's going on. And so, hopefully, if you want more detail, it's in that paper, and the website has a lot more information. So, EPSS is a community and data-driven effort. We've got a special interest group over at first.org, same place that CVSS is being generated out of. And it is for estimating the likelihood, basically the probability of exploitation activity being observed in the wild. And the other thing is the primary goal for EPSS. There's actually several sub-goals, but the primary goal is to assist network defenders in prioritizing the vulnerabilities that they have to look at. And basically, EPSS is a real-time engine that uses real-world exploitation activity. We actually have a ton of data coming in about exploit activity, and then we use telemetry data, if you will, or metadata about vulnerabilities to try and understand what about these vulnerabilities may cause exploitation activity or be correlated with. EPSS very simply is these three columns on the right. So if you hit the EPSS website, first.org/EPSS, there's a data and stats page where you can click on that, and there's a button at the top that says download, which is the link in the middle here. And basically it's an output for every CVE on a daily basis. It outputs a value between 0 and 1. And that's the center column on the right there. So just a sample of, I don't know, 20 CVEs or so. And this is from yesterday. And then for each of those, we get a percentile too. And that's basically what percent of vulnerabilities are rated at or below this. And so it's the same information as the middle column, just presented differently in a ranking. So like that first one is rated 0.003, and 68% of these vulnerabilities are rated at or below 0.00363. And that gets into sort of an interesting part about the distribution, right? The distribution is highly skewed to the left.
But before Jay moves on, and it's worth noting that we can look at that as graph, what that probability actually is. And so that probability is the likelihood that we'll see a particular CVE be exploited in the next 30 days anywhere. So that some attacker is going to attempt to use that, or attacker, some evidence that somebody is using that exploit to try to compromise a system somewhere in the next 30 days.
Yep. And it's also another question that'll probably come up fairly frequently is that we're observing exploitation activity, not that it's successful exploitation activity. We don't often don't know if it's successful or not, if there's even a vulnerable system behind or targeted by that exploit. It's just a bunch of sensors detecting exploitation activity in various different ways. But so getting at the distribution, this is the actual probability in that chart down there. And this is for all, what was it been, 197,000 or something that we're at right now?
We are creeping up very close to the 200,000 mark for CVEs.
Yeah, published CVEs. Reserved were well over 200,000, but published. And so all EPSS is scoring is those published CVEs. And these are updated daily. But you can see that the majority of these, 70,000 or so, are very, very low. I think that's every 2% is a bar. And so 2% or less, probably, 90% of these are 2% or less. But I mean, like you can also see if you squint in real tight, you can see a little bump on the right, towards the right. And this is what we're trying to do. We're trying to separate those that are being exploited versus not being exploited. And another thing is that this is pre-intelligence. And so if you have intelligence that something is being exploited, don't even check EPSS, right? This is pre-intelligence or alongside intelligence that if, intelligence might report a few hundred CVEs being exploited. We're seeing on average, I think we're seeing 8,000 to 9,000 exploited in a year in the data that we have. So, but if you have data, use that, don't check EPSS. And we got a question here from Bill Frank saying, does that mean that EPSS does not include known exploited vulnerabilities? It does. You're typing an answer, Ben?
Yeah, but it's essentially the same thing that you just said, which is, if you happen to know that this CVE through your own private intelligence or a public source like the CISA's known exploited vulnerability list, that it's being actively exploited, and that is within your organization's network, go ahead and patch it, go ahead and take care of it, remediate it, use that as like as a primary signal. But this gives us that signal for all the other vulnerabilities besides those ones that are known.
And the other thing too, for all of the data that we have, we're seeing between, depending on how you slice it and time and vendor, platform, all that stuff, we could see, about 5 to 6% of published vulnerabilities being exploited, which means this chart that we're looking at is probably fairly accurate. And we'll talk about the accuracy. Actually, we didn't include the calibration one, but we would expect 94% to be, if we had perfect information, 94% of these vulnerabilities would be 0, and about 5-6% would be 100% probability. And so you would expect something like this, as opposed to, if we grab the same information for CVSS, we're seeing about 51% of all published vulnerabilities are rated as high or critical, which, of course, I think anybody who's been around the field has intuitive information or knowledge about CVSS. So, all right, so let's talk about integrating it. We're going to talk, I'm going to take sort of a risk-based approach. And I think that this just sort of plays into the prioritization scheme. Not that I think every CVE should have a formal risk analysis or anything, but just the approach, the thought of risk applies to prioritization of vulnerabilities. And one of the common formulas is this threat times vulnerability times impact. And as I say in the slide, it is not a formula, not a math formula. Don't plug in numbers and multiply. And if you search the internet, you can find a ton of discussion about this, and we don't want to beat that one down. But essentially, EPSS is not that entire formula. It is purely just threat, because remember, we're looking for trying to estimate the probability of exploitation activity, not to value your asset, not to look at any compensating controls you have, or if this vulnerability is buried 10 layers deep in the network, anything like that. So it is purely just a threat. So if you want a full decision, prioritization decision, you need to understand that EPSS is a part of that decision, not the whole decision. But as this formula is often used to discuss, if any of these are 0 or near 0, your overall bad stuff is going to be low, right? So if no one is ever going to exploit it, you can have your front door wide open and not have a worry, if no one is ever going to walk in. And that's what we're trying to understand, is what is the probability that someone's going to, try and exploit these things. Real quick, if we look at like NIST SP 800-35, the guide for risk assessments, they have this chart in there talking about what should be considered in a risk assessment, and EPSS is right there. Again, not the whole box, just a part of it. We can also look at the FAIR taxonomy, and they have this taxonomy here. And similar things, basically, it's on the left is the threat, on the middle is vulnerability, and then the right side is impact, loss, consequences. And so EPSS is just over there. So hopefully we drove that point home. All right, building blocks of EPSS. So what goes into EPSS? As mentioned, it's a data-driven process. There is nobody at a keyboard saying we think this is bad, or let me assign this particular thing a high, medium, or low, anything like that. And so it's all data-driven. So at the core of it is ground truth. We have exploitation activity from Fortinet, Alien Vault, Shadow Server Foundation, F5 just joined us. We've got Cisco and various elements in Cisco donating, and I feel like I'm forgetting some of the ground truth in there. Anyway, gray noise. Almost forgot gray noise. And so we're looking for evidence of exploitation activity. And though they're providing it from all of the different ways that they are capturing and recording that information, and we're doing that on a daily basis. So a lot of people think when exploitation occurs that the barn door is open and all the horses run out and that's it. But that's not really the case. That when we see exploitation activity, it may mean that it'll stop. We may see it once or twice and then never see it exploited again. Or we might see it sort of dribble along versus something, like Log4j, I think, has set off every sensor every day for the past 14 months or something. Let's see. The other data that we have are vulnerability attributes. So things like the vendor, the product CPE stuff, CWE, CVSS, all version 3, which Ben can talk about at length, but we've converted everything to V3. We've got the age of the vulnerability description. We use the text and do some NLP to grab tags and various attributes from the description. We've got references, and those references are tagged by NVD. And there's several other areas, a lot of complexity. I think we're over 1,400 features in the model.
Right. And I think it's worth pausing here just to mention that all of these attributes are kind of public, or not all of them, but many of them for the vulnerability attributes are publicly available, meaning that they're out there and that you could look at them. But there has been a lot of work going into things like CVSS v3 has only existed for the last 5 years. And so we have gone back and done some fancy machine learning to backfill that and make it so that's available for all CVEs. Some of the description stuff, blobs of text, are not really conducive to putting into machine learning models like this. We've done processing on that to pull out the interesting bits. The same thing with some reference information. So, a lot of the stuff that goes into EPSS, you might think like, oh yeah, I've got that data. But the truth being, like, getting it into a usable format has been an interesting challenge and a fun thing for us data nerds to put that together.
Yep. And some of the other things, I want to try and rush through some of this a little bit,
Sure
but published exploit code. So we look at exploit DB, Metasploit. We've got a special classifier running on GitHub trying to pull out exploit code from patches and other things that people may paste down there, get in there. We've got a lot of different analysis discussions, listings, things like Google Project Zero, the known exploited vulnerabilities list, Twitter, other things in there, some of the site things. And then the third one actually was offensive security tools and scanners. So things that may be used by pen testers to identify weaknesses. We're finding some correlation there with exploitation activity, thinking that maybe some of the attackers may grab some of these open source tools and use them on targets. Okay. The obligatory mention, this is a lot of the data behind this we've gathered and we've built into a feed, and we're donating it to EPSS for use in this, but it's also available for customers if anybody is interested.
Boy, Jay skipped over that real fast. So we are talking about EPSS. This is an open community effort. But we are, it is Scientia, and we've put a lot of work into this. There's lots of valuable information in the Exploit Intelligence Service. Contact us for more information.
And we did get a question in chat. I think it just disappeared for some reason. But if you see activity exploiting a vulnerability once or twice only, how does the EPSS score change over time? So we're going to get under the covers a little bit here, but if we only see a little bit of activity, it's basically the probability, you could think of it becoming non-zero, but definitely not 100%. So if you see, if you're flipping a coin and you flip a coin 100 times and you get 2 heads, the probability of getting heads going forward, you could estimate is going to be low. If you had 100 tails, you might have a different estimate. If you get 50 heads, you might have a different estimate. So that's what the model is doing sort of under the covers. It'll factor that in and see, hey, there's some exploitation activity, so it's going to be a little bit higher than some of the others, but it's not towards the top.
Right. And just to answer the more kind of generic part, like how does the EPSS score change over time, is my favorite answer, which is it depends. So it depends a lot on the other attributes of the vulnerability. Part of the reason we've skipped over this, you can look at the paper, we're using a gradient boosted tree to actually do the predictions. And so it handles all the nonlinearities. And so actually, the effective age is changing over time. So like, maybe it starts high and goes down, then comes back up. But depending on the attributes of the vulnerability, that relationship can change.
Yeah.
And that's why EPSS updates daily, and you can get fresh new scores with some of those changes on a daily basis, because it's looking forward to the next 30 days, which we're probably not going to talk about given that I just looked at the clock.
Right. Yeah. And I think we'll skip over the test train bit, but that's probably fine. So let's talk about why you should trust EPSS. We're going to get a little nerdy. This will probably be Ben's wheelhouse here. But essentially, we're going to talk about 3 ways that we measure performance, talking about coverage, efficiency, and amount of effort. And the coverage and efficiency are precision and recall for those who know the term from information theory and other machine learning classification stuff. But we call them coverage and efficiency because it's a little bit more intuitive for vulnerability management terms. So same exact math, everything about it is precision and recall, but a lot of people don't associate terms with, the meaning of those. So let's jump into it. So basically, creating a Venn diagram here, the gray circle is all the vulnerabilities that we can look at. And then red are things that are being exploited in the wild. And specifically, as we're looking at these plots, we're going to look from December 1st to December 30th. And we're going to kind of gloss over why. But essentially what we're doing is we're going to grab our state of knowledge, what we know as of December 1st, and we want to make a prediction. Since this is all data driven, we can pull things from December 1st and say, what is our state of knowledge? Given the state of knowledge, do we think this will be exploited or not? And we do some prioritization. So like in this case, we say CVSS 9 and above. Let's grab all of the CVEs that were 9 and above as of December 1st and say, let's remediate these. And that becomes the blue circle. And then from December 1st to December 30th, we're going to look over a 30-day window and say what was actually exploited. And that's the red window. And so in this case, you can see everything that we said we should prioritize is in the blue, and there's some overlap with the red. So we got some stuff right, but the red is sort of sticking out there. There's a lot that we sort of missed. And so coverage and efficiency are going to measure that. So let's start with efficiency. And that essentially says, how efficient was our prioritization? How efficiently did we allocate resources? So we look at the size of the blue circle that becomes essentially the denominator. This is everything we did. What proportion of everything we did was actually exploited? So what proportion of the blue is covered by the red? And coverage does the same, but from the red perspective, from the exploited perspective. So the coverage is how good is the coverage from our security perspective? Essentially, you probably want 100% coverage, and depending on your budget, you can talk about efficiency second. But you want to cover that red circle. So this is saying out of everything in the red circle, how much was prioritized? How good, from a security perspective, was our effort? And that's what coverage is talking about. From a practical standpoint, we can grab some absolutely silly and basic heuristics.
Now, I will say these are not absolutely silly. For example, the Department of Homeland Security recommends that you patch everything that's CVSS 7 or above that you can patch. So that is like a strategy that is mandated by the US government. But I would agree that some of these are a little bit strawmanish in that nobody's only going to remediate just these subcategories. But I think it gives us an interesting kind of yardstick to say how well is EPSS doing against these kind of well-known classes of like, this is where all the vulnerabilities are.
Yeah. So if we take CVSS 7, the second in the upper left there, second to the right, it says 57% of CVEs. This is back on December 1st, remember, and this actually was just those with natural CVSS 3 scores, not the work that we've done. And so 57% of those had 7 and above. That gets us 82% coverage. So out of everything that was exploited in the month of December, CVSS 7 above got 82% of that. That's quite good from a coverage perspective. But you can see efficiency is at 4%. 3.9%. So it's rather low efficiency. That blue circle is quite enormous.
Yeah, you're essentially
you're
doing a lot of work you don't have to, in the sense that you're fixing things that nobody is trying to exploit.
Yeah. And like right underneath that, we have Microsoft with 18% efficiency. So you vastly improve your efficiency and you get a coverage about a quarter, 23.6%, but you're only doing 5% of the CVEs are marked as Microsoft. I think the interesting two are the two in the bottom right, where you compare Metasploit and the known exploited vulnerabilities list. If you do Metasploit, you get really, really high efficiency. So basically what that means is that a lot of the vulnerabilities in Metasploit are being exploited in the wild. And whether that's correlation or causation, we'll leave that to the interpreter. But coverage of 14%. And so you could have a very efficient strategy as part of your decision if you say, let's make sure we have everything in Metasploit remediated. And then the KEV, a lot of people say, hey, there's things on the KEV that EPSS scores low. And I think the vice versa is true. If we look at everything that we've seen exploited in December and we look in December 1st for what's on the KEV, we see that we get a coverage of 6%. That is 6% of everything that we saw exploited in December was on the KEV. And then the efficiency, so we saw about 53% of those on the KEV with exploitation activity. So we didn't see exploitation activity for 47% or so of the vulnerabilities on the KEV. And I think we're going to breeze through this part.
I would agree that I love these pretty dot plots that tell you exactly why we're predicting the future and why that's important. But Jay is just going to rapidly skip these and know that we did the right thing, and we did fancy machine learning in the sense of like we used the standard what should have been done. We did, and we did the right thing. And please trust us. If you don't, we're happy to talk. We're happy to talk to you more about it later. Or you can read the paper and then come to us and talk to us more.
But I think this is probably the key slide, where essentially when we're training the algorithm and we're tuning and finding the optimal things, we're training up until, like in this case, we trained up until November 1st. And then we essentially skipped the month of December and had that model predict on December 1st. And then we looked at the exploitation in December, like we did in the previous charts, to say, how did that model perform?
Yeah.
So. And we've got some different techniques that we apply as well. But when we look at the evolution of EPSS, so this current release that we just did a week ago was for V3. And you can see on the left, these are the same plots as before, where we have like, if you do a CVSS 3 threshold of 9.1 and above, we want to maintain that same level of effort. So that's about 15% of CVEs being remediated at CVSS 9 and above. And if we keep that blue circle the same, you can see as we go through the evolutions of EPSS, when you get to V3, blue circle is about the same size, but it's covering a lot more of that red. So you're a lot more efficient. We go from an efficiency of 6% with CVSS 3 with a 9.1 and above to an efficiency of 24% with EPSS V3 and a coverage of 90%, which is great. And that threshold then, like if you said, remediate 0.02, 2% and up in V3. And then if you maintain the same coverage, so like in that CVSS strategy of 7 and above, we get that coverage of 82%. If we try to keep that coverage at 82%, you can see how the level of effort drops. So 7 and above is about 58% in that particular plot. And then the EPSS V3 is 7% effort. So, and with that, we'll try to leave some room for questions. But essentially, just know that EPSS, all this data, all the scores are generated daily, and they're easy to download. It's just a CSV. You can open it in Excel or whatever sort of data analysis platform you may have. And you can triage. We talk about triage because remember, we're talking about that threat, vulnerability, and impact, and this is purely the threat. With lower threat comes lower risk, and so it could be a triage mechanism. But if you have a very important asset that has a very low probability vulnerability, the impact may offset some of that threat. And so you have to take all of that into consideration in your prioritization mechanism. Third point, we've got, we didn't dive as far as we wanted to into the machine learning, but we try to leverage the feedback. We try to look at that exploitation activity, that ground truth, very important part. And last thing, EPSS, of course, is data-driven. So that means we can react in real time as soon as exploit code is published. You should see the score react to that. But I mean, like it may overlook unverified data subtleties.
And I think what we mean by that is we often get feedback of like, hey, this thing got published today, and I know it's already being exploited in the wild. And that may be true. And if you know that's true and it's on your systems, like go patch it. But some of those signals may take a little while to percolate up to the data that we're actually ingesting and using. And so it may be tomorrow or the next day before you see the EPSS score jump. And so, and also, I would encourage you to consider your sources on saying like, I know that's I know that's going to be exploited in the wild. Because the model is built on kind of trying to suss out those things and figure out when there are those kind of subtleties that are there. So yeah, I think that's the cool part, is that it is data driven and we can measure how right it is, and hopefully you agree that it's right most of the time.
Yep. And with that, we can open it up for questions and try to address what people might be thinking here and wondering.
I mean, I'm happy that people asked a few times throughout the talk, just because it's always fun to interact. But from like a personal perspective, EPSS is also something super fun to work on, because I think taking a data-driven look at this problem that things like CVSS have tried to solve for years and years is really like interesting in all aspects. It's an engineering challenge, from setting up the infrastructure and doing the coding. It's like a statistical machine learning challenge, from what features do we use and how do we do the training and the testing? How do we do model selection? And then just like practically from a security standpoint, when it spits out numbers, do these kind of make sense? And also like kind of the socio-technical convincing people that this is like a good thing, and working in those groups. It is a really fun thing to work on. If any of that sounds interesting to you, please join our SIG. It's open. Go first.org/EPSS, and get the information.
Well said. There's a question that just came in. What does vulnerability represent in the threat times vulnerability times impact formula? So typically, there's different interpretations, but basically the vulnerability represents the lack of strength. Basically, it's a measurement of the defender's ability to resist the pressure being put on by the threat. And so that's kind of an important thing, because we've been talking about vulnerabilities, which are rather specifically defined as a CVE. And there are quite a few vulnerabilities that would never qualify for a CVE because of CVE practices at MITRE and such. But vulnerability in that particular risk perspective is all about the defender's ability to resist the threat, or lack of ability to resist that threat, the pressure coming from an attacker, or any number of pressure or threats that may come across.
Yeah,
that's a very good question. One of the things that I know I find really interesting, and we're actually working on a second paper right now to dig into this, is a descriptive analysis of the data that we're working with, and that is trying to understand, like there was a vendor who just put a stat out, I think last couple of days ago, but said 50% of the vulnerabilities are exploited in the first day. And that is absolutely not the case that we see in our data. And turns out that they were looking at, I think, 120 vulnerabilities total. And the way that they chose them and set them up, 50 of them were exploited on the first day, which is totally feasible. That is totally feasible. But I think what's interesting is trying to understand what this does look like. I mean, like, should we be more concerned with the concept of 0 days, or, where n equals 1 or 2 days, or should we be more concerned about the corners of our networks? And like, for example, we looked at Microsoft, and we actually see the peak and the proportion of Microsoft vulnerabilities peaking between 6 and 8 years after publication of the vulnerability. That proportion-wise, more of these 6 to 8 year old vulnerabilities were exploited than the first year were being exploited. And so I think there's going to be some interesting things coming out of that paper. So. Okay, if there are any other questions, feel free to jump in. Otherwise, Ben, it's been a pleasure.
Yeah, always fun.